Hello class. In this video we begin the discussion on section 6.6 in your note packet on the area between two curves that begins on page 93. So here I have the coordinate plane. I'm just drawing the first quadrant, and I have the graph of two functions in this coordinate plane. The top function I've labeled f of x, and the bottom function I have labeled g of x. And we are interested in the area between those two functions from x equals a to x equals b. Well, we know from the previous section, right, we know how to calculate the area below the graph of a function, right, below a curve and above the x-axis from x equals a to x equals b. Well, to find the shaded area in red here, all we have to do is calculate the area below f of x and above the x-axis, and then subtract from it the area in white here below the function g of x and above the x-axis. So calculating the area below f of x and above the x-axis, and subtracting the area below g of x and above the x-axis gives us the area, the shaded area in red here. And we can write that as our definite integral, right? The shaded area in red is equal to the definite integral from x equals a to x equals b of the top function minus the bottom function. That's what top minus bottom means. Now you can also write upper minus lower instead of top minus bottom. And the top function is labeled f of x in this case, and the bottom function is labeled g of x. So to find this area in red, right, we just take the difference, take the top function minus the bottom function, and we integrate that difference from x equals a to x equals b. Okay? Now, most of the examples we're going to be working, the area we're going to find, right, the two functions are going to cross each other's in two locations, and we're interested in the area sandwiched between the two functions. So here I have the function g of x, right? This bottom curve here is the function g of x, and the top curve is the function f of x. And we're interested in the size of the area, right, that's sandwiched between those two functions, right, the shaded area. So in this case, you won't be given x equals a and x equals b. We'll have to calculate what a and b are by determining where the two functions intersect. And once we know for what values of x the two functions intersect, we can then use our definite integral over here to find the area between the two functions. Okay? So just remember, this is the x-axis and this is the y-axis in the coordinate plane. So on page 93 of your note packet, we have example 1. And we want to find the area sandwiched between these two functions. Okay. So here's the this red curve, right, is the top function. This blue curve is the bottom function, right? We're interested in the area shaded in black here, right, sandwiched between these two functions. The top function is y equals square root of x. So if you want to, we can label that f of x. And the bottom function here is y equals x squared. If you want to, we can label that g of x. What x equals a is and what x equals b is where the two functions cross each other. Okay? So remember, this is the x-axis, this is the y-axis. And so by visual inspection, right, you can see that the two functions cross each other here at x equals 0. So a equals 0. A equals 0 in this case, right? And then the two functions cross each other again here at x equals 1. And so b equals 1 in this case. So A, right, they cross here at x equals 0, and they cross again here at x equals 1. Now you can always do algebra if you want to verify that's the case. Right? You set the first function x squared equal to the second function, which is the square root of x, or x to the 1/2. And then if you subtract x to the 1/2 from both sides, right, you have x squared minus x to the 1/2 equals 0. And then if you factor out x to the 1/2, if x to the 1/2 times x to the 3/2 minus 1 is equal to 0. And by the zero product property, right, x to the 1/2 has to equal 0, or x to the 3/2 minus 1 has to equal 0, and you end up with x is equal to 0, or x is equal to 1, okay? Which are the two, which is A and B down here. So to calculate this shaded area, you're going to take the definite integral from x equals a to b of the top function minus the bottom function. Well, a is 0, right? B is 1. The top function, right, is the square root of x. The bottom function is x squared. And now, right, we can use the difference rule of integration to find this antiderivative. Well, you know you have to write square root of x as x to the 1/2. And now, excuse me, the limits of integration are 0 and 1. And you know the antiderivative x to the 1/2, you add 1 to the exponent, you get 3/2, divide by 3/2, the same as multiplying by 2/3. And so we have 2/3 times x to the 3/2. And then the antiderivative of x squared, add 1 to the exponent, you get 3, divide by 3, and we have minus 1/3 x cubed. And then our limits of integration are x equals 0 to x equals 1. So now you plug in the upper limit of integration, right? You plug in 1 for x, and we have 2/3 times 1 to the 3/2 minus 1/3 times 1 cubed. You put in 1 for x, and then you subtract, and you put in 0 for x. Well, you know each of these terms are going to equal 0 when you put in 0 for x. Right? So we're going to have minus 0 minus 0 in parentheses, which doesn't add anything. And now you got to do that arithmetic. 1 to the 3/2 is 1, so we just end up with 2/3 in that first term. And then 1 cubed is 1, and 1/3 times 1 is 1. So we have 2/3 minus 1/3, and 2/3 minus 1/3 is 1/3. Okay. So the area, the black shaded area, is 1/3 square units. We're not given the units, but you know that area is units squared. Okay? And we're done. That is the size of this area, shaded area in black.